Okay, guys. So thank you to join. And this is Puneet this side. I hope few of you already aware of me and the VLSI expert. And if you have just seen the LinkedIn post and all, so my profile is basically the extraction, STA, and the physical design. Like the reason I'm talking about in the reverse direction because that's the way I have worked in the industry, and before that, like PDK and the technology files and all. And these 12 weeks, I'm going to be one of the trainer. Along with me, Kanika and Rajat will be there, and they are going to help you whenever it's recorded. But mostly, like all the conceptual related thing, I will take care. And when it comes to the test cases and all, or some like practices and all, if you will talk about, then Kanika and the Rajat will do the things. So whenever we need Rajat, Rajat is going to be the part of this part. Now, as a part of the orientation, I think so. The purpose of today's session is just to give you an idea, like, okay, what we are going to cover. I will just give you the idea, like, okay, these are the topics, the way we have designed. So I've just captured a couple of things in a document format, so you can just check that particular part. And if you are looking for something else, then we can discuss whether that is possible or that is not possible. Okay, so like that's where the things are there. Another thing is like I would like to understand you people, like what is your background, what on which particular tool you're working, and what is your expectation as a part of this particular course. So this is basically the overall orientation session. Okay, and after this, we need 4 5 days just to create your credentials and all, like login credentials, so that you can access the prime time and all. So next session, we'll see either we will do on Tuesday is going to be little early, like the credentials will not be there. I would like you to just do that particular part. So next session we will do on the Friday. I think the way we have proposed the timings, it is like Tuesday, Friday, and Sunday. So next session we will do on Friday night, same time. We'll do in that particular way. Okay, so let me just share with you first the course content so that that's going to be a base for our discussion. Hmm. So Tuesday, Friday, and Sunday, 7:30 to 10. That's where we are planning. As such, it is a 12 week, and then we have the 2 week of extra time just for the two lectures, so that you can just do the remaining part, whatever the work test case we will give, or the design we will give if you want to do couple of experiment there just for the learning purpose. So that is like in a tentative one, but let us suppose if the whole course which we are planning is going to take more time, for example 12 to 13 weeks. Okay, or 12 to 11 weeks. As such, is not going to be happening 11 week. Usually it happens the more than that. So if it will be like 12 to 13 week, then you can just consider it like, okay, you will get another 2 week of two lectures. So that usually happens. Now, as a we are divided as a module point of view, but yes, there are uh, these modules, the day-wise schedule. Maybe next time when we will see each one of us, like I will share with you the day-wise schedule. Even on the portal where you have joined, we are going to create this module and the day-wise schedule there. Right now, we have just planned it in this particular way. So like when we are talking about the introduction, so the introduction is basically the basic idea. So the purpose of this particular module is not to just tell you everything. So I'm just taking this particular module as a top, like the course as a top to bottom approach. So first, I'm just going to give you the bigger idea, like, okay, in industry, what happened when it comes to the violation, then what violation we are talking about, when we are talking about the ST optimization, the clock related thing, then what is going to be happen? So those kind of things we usually do it. Okay. Similarly, when it comes to the violation, like okay, how the different kind of violations reports are there, so that those who are working in the industry, they can directly just see this particular part, like okay, these kind of the violations maybe they have seen in the industry. And if you're a fresher or so, then you will come to know like okay, in a STA what kind of reports you will see. So that's basically the part we are talking about. Now when where it's written as a hands-on in the sense, this is something we are going to show you, not the snapshot. It's not like, okay, I will just show you the picture of that. And the tool, how the reports are going to be generated, those kind of a things we will just show you in a particular design. And then there are a couple of standard reports, like I was just talking about. I just mentioned a couple of reports here. Maybe it can be more than that or the less than that. Not the less than, because whatever I have mentioned, that definitely I'm going to show you. But still, if at that particular time it looks to me like, okay, there are the few more reports, I will just show you that particular time. Like here it is written like, okay, we are going to just run the script, dump the report and explain the reports. That's all. So don't, so the reason I'm just telling you like, okay, what is the reason of this particular module? So don't be in a hurry. Don't ask at that particular time, like, okay, what is written there? We are not going to explain a lot at this particular moment. Okay. But this is going to set a pace of the course. Like, okay, the base of the course, like, okay, these are the things usually happen and we have to just work on that particular point. There's a second module. Now we will come back and we will just discuss all the inputs and output files of which is required as a part of a STA. Now, for example, if we will talk about the SDC, SDF, SPEF, SBF, WLM, ITF, TLU plus, NXT file. And most of these files we are going to discuss what is the information of this file, how it is written. So I'm going to explain you like, okay, what is the syntax and how you can read that particular part. Few of the things maybe you're not able to understand if you're the new in as a part of a STF, for example, the SDC. Now maybe you can ask like, okay, Puneet, what is the constraint and all? So that's okay. I think in the constraint section, we will talk about that. But at least you will have an idea like, okay, whenever I'm going to talk about the SDC constraint file, so what all the different things are written as a part of SDC file. That is going to be my main goal. So tomorrow, if I'm saying that, okay, there's a RC related information. Now, RC is a resistance and a capacitance. Now, if I'm saying there is a wire, for that particular wire, we have to come up with the RC related information. Now, that RC related information is a part of a SPEF file, SBF file, WLM file. These kind of terminology, when I'm going to use it, at least you will be able to understand, like, okay, these files are specific for this particular purpose. So that's basically the one of the thing. Now, when it comes to the netlist, Verilog, DB files, so obviously in all the designs, we have the different Verilog netlist files. So we are going to talk about that particular part. In terms of the .lib file, UPF file, LEF, DEF, OCV files, AOC files, how it is written, all those different kind of modeling related things. So we will talk about those particular part. So the purpose of this module is just to give an idea like, okay, in a whole VLSI industry, what are the different kind of a files you're going to work day in, day out. So it's not like that there is a delay there and 2 nanosecond. But what is important, like, okay, how that particular delay has been captured in a different files, because at the end of the day, you're going to use the EDA tools, and EDA tools where there you are not going to just enter the 2 nanosecond. It is going to read a particular file which has been designed and developed by someone else and some specific format. So we are going to discuss that particular part. Again, here as a hands-on, when I'm talking about, mostly it's not something which you have to do, but yes, you will have the access of the different files. Later on, you can also see, you can also go through each and every file. So that's basically the hands-on and the lab part I'm just talking about. So till this point, it's not like there is a test case and you have to just run it and you have to just figure it out. But yes, there are different files you have to read and you have to just go like, okay, see like, okay, in which directory, which file is there, just to understand all those particular files. So that is the second module we are going to talk about. Now, once this is done, then the third thing, which is very, very important, that is the extraction flow. Now, when I'm talking about the extraction flow, so extraction flow is, we usually say it's a parasitic extraction flow. Parasitics in the sense, resistance and the capacitance and inductance is also part of a parasitic, but since we are talking about the digital, so we will talk about the resistance and the capacitance. So RC extraction flow. Now, extraction in the sense like if there is a design in particular design, how you're going to extract this R and C of a particular wire. That is basically the whole thing. Now for this, we usually use StarRC, which is a parasitic extraction sign-off tool. So we are going to tell you like, okay, for that, what are the different files you need? For example, in a Synopsys, there is a file, ITF file, interconnect technology file. So we are going to talk about like, okay, what is written in this? How the files are going to read, like how the star RC is going to read this particular file. What is basically the resistance and the capacitance of a particular wire. We are also going to discuss about the wire related terminology. For example, the width, thickness, as a designer, what you can change it, what you cannot change it. As a from the foundry point of view, how things happen, what is the metal stack, okay, and what are the different type of capacitance, the resistance, modeling, all those things we are going to discuss and how those things are going to be the part of it different modeling files. So even we'll discuss about the spec file also, like okay, how if there is a spec file, how you're going to read it. Now the important thing is like apart from the hands-on like an extraction execution debugging part, like okay, how you're going to debug in terms of the running the star RC. Here the lab part will be there. So basically we will give you the test case. There is a design. In that particular design, we will tell you, okay, this is a setup, how you're going to run the star RC, how you have to do the setup of that. What are the different ways you can extract the these R and C? Like there are other option. You can extract only R, only C. You can extract the coupling capacitance. Now, which coupling capacitance we are talking about? And the different corners. Now, what corners we are talking about? Like there are the something known as a parasitic extraction corner, like typical C best, RC best, C worst, RC worst. So those kind of a things we are going to discuss as a part of a third module. So this is going to be a comparatively the bigger module because most of the time this kind of information you will not see in, I will say, most of the courses. And so I would like to focus on this particular part in a great detail. And once you are clear with this, you will come to know like, okay, from the foundry perspective, you are able to understand a lot of things. Okay, so that's our third module. Then the fourth module, which is, if you will see, that is a signal integrity analysis. Now, maybe you're just thinking like, okay, how come the signal integrity analysis you are talking about here? But the important thing is here, if you remember, I just mentioned there is a coupling capacitance. So there is a two wire, then those two wire, there is a capacitance between those two wire. So signal integrity is something known as a like you can say in the quality of the signal. So in a particular wire, obviously there is a some signal is flowing. So that particular signal is going to be affected because of the crosstalk, okay, because of the nearby wire interference, and that's the reason we are going to discuss this particular part at this particular stage in the starting itself. Most of the time, people do this thing at the end of the session or maybe the one session or the two session. But what we are planning, like, okay, we will just give you an idea about this thing at the starting itself. Like in the fourth module itself, we will just talk about this thing. Noise analysis, maybe we will not cover a lot, but we'll see maybe theoretically or depending upon you people. So this is the way I have designed this particular part. Like conceptually, I'm going to just to tell you like, okay, what is important in your spec file. If that portion is there, then you can do the signal integrity analysis. If that information is not present, you cannot do the signal integrity analysis. So those kind of things we will discuss as a part of a fourth module. This module is not going to be very big. It's just like in a conceptual part at this particular place. And then later on, as we will do the reporting and all, then there we will discuss more in detail. Then the fifth module. So till now we were talking about the resistance and the capacitance, that means the wire related thing. But what about the gate? What about the different other concepts? So the third module where I'm going to talk about the different wire related thing, what is the dimensions and all. Same thing we will talk here also. So something I will just discuss there, and then remaining thing I will discuss here, like CMAX, CMIN related part. If I have discussed there in a great detail, then I will just discuss here only the gate related part. If it looks to me at that particular place, you people are facing a problem just to understand, then I will discuss those things at this particular stage. So I just kept a flexibility, like, okay, where I have to discuss that particular thing, but like the gate related thing. So if we are talking about the NLDM models, so we will talk about that particular part, like, okay, what is the input side, output side, how the delay is going to be calculated, what is that particular equation, like if from the tool perspective, how the tool is going to calculate the delay and everything. So those kind of things we are going to discuss here. So it's basically the modeling of the wire or modeling of the gates. That's what we are going to talk about at this particular module, at this particular, the module part. Then sixth module, which is like timing arc and the dot-lib file. So once we are finished the module 5, which is more about the modeling part, NLDM part, then the important thing is after the NLDM, the next thing is how you're going to write it into a particular file. And that's where the dot-lib come into the picture. Again, there may be a certain topics where there are going to be the overlap between the module 5 and the module 6, because when I'm going to talk about the NLDM, then obviously I have to discuss about the .lib file also. But yes, I just kept it as a separate one because there are a lot of things we have to discuss here, like for example, the timing arc, which is a very important topic, or you can say the like the concept which all of us should know before doing any kind of a timing analysis. And then we will also talk about as a labs and all, like, okay, how you're going to extract all this information from with the help of the tool, like in terms of the how many lips are there in the that particular lib, how many cells are there, how you're going to report the different kind of attributes in terms of the constraint which is defined as a part of a dot lib. So all these information mostly in a sixth module, or the fifth and the fifth module is going to be mostly in terms of the delay concept modeling and all. And sixth is mostly around the .lib file. So if I will just keep it in this particular way, Liberty file. So from the tool perspective, how you're going to read the libraries, what are the different kind of libraries, what information is there. So that's concept, plus from the tool perspective, how you're going to extract that information. That is important. So conceptually, obviously, I can just tell you, but from the tool perspective, how you're going to extract, that is something we are going to talk about in the module 6. Then, like I told you, there are the different kind of a .lib files. So now those .lib files, different kinds means based on the different operating conditions. Now PVT corners, process voltage temperature corners. Okay. How you're going to create when you're going to do the analysis, then PVT corners are there, RC corners are there. And then how you're going to blend, how you're going to create a different scenarios. So your gate and the wires is a part of your design. Now, I was talking about in a wire, there is a RC corners, resistance and the capacitance corner, like Cmin, Cmax, typical, these kind of different informations are there, like different uh, corners are there, which is having the different dimensions, the different R and the different C and the different cases, corners you can say. Similarly, for the PVT is a different process, different voltages, different temperature. The same gate will have the different delay values. Now, when we are going to do the analysis, the important thing is we have to make sure like in all the combination. That means PVT1 and Cmax, PVT2 Cmax, PVT3 Cmax, then PVT1 Cmin, PVT2 Cmin, PVT3 Cmin. So all this, whatever the number of different combination, how things are going to happen, how you're going to do the analysis. So those kind of things we are going to talk about. Like here it is mentioned like okay, multi-mode, multi-corner, MMMC analysis. So that we are going to talk about like okay, in one design, if you have these kind of things, how you're going to set up the flow, how you're going to uh, take out the values with the help of the tools, what are the corners. We will talk about that particular part at this particular stage. Then we will go one more step further in terms of analysis. So now you have an idea like, okay, yes, we can create the corners, we can do this thing, we can create the different scenarios, reports. You're good with the concept and everything. But important thing is now when you're going to do the analysis, what are the different challenges you will face? Now, for example, if you want to give the tool single library, then single library you're giving. So basically, if you have the 10 different libraries, you have to do the 10 different analysis. Or you are saying, look, I am going to give the two libraries, three libraries at the same time, and then do the analysis. Then how the tool is going to read those libraries, what is the default way tool is going to do the analysis, or if you have to change something, how you're going to do that particular part. So from the eight module is something where I can say hardcore analysis related thing is going to happen. So still seventh module, yes, like we are doing we are trying to understand the tool, how we will extract the information or how we are going to set up the flow. But the eighth module is something from where we will talk about like, okay, how I'm going to do the analysis in the different scenarios. So that's the reason we are saying advanced timing analysis part now. Okay. Similarly, a ninth one, now we will talk about again, the next stage of things where we will talk about the deratings. Now, there are the people, they are saying you're using a more pessimistic approach or maybe the optimistic approach. Based on that, they have the different way to do the analysis. We will talk about that particular part like OCV, AOCV, SOCV. Okay. And then what are the different kind of violations? So we will talk about the design rule violations. Now, we are not talking about the till the time setup and hold violation. That is a different thing. Okay. We will talk about DRV, which is a something you should fix first, even though they're the setup and hold. So most of the people think like, okay, when it comes to the our timing analysis, ST is a setup and hold. But important thing is that is suppose there are certain DRV violation and the setup and hold violation. So everyone is going to ask you like, okay, first give the priority on the DRV. And then the STN setup comes into the picture. So ninth module is basically on the priority basis, like what you are supposed to take care of the DRV. That's what we are going to discuss at a module 9. So these are a couple of DRV checks. What is the importance of these checks? Why we have to do it? How we have to do it? If we have to fix it, how we are going to fix it? So all those things we will just do at this particular place. Then the next thing come into the picture, which we usually say that what are the different timing checks and what are their groups. So there, in terms of a design, if I will say there is a uh, multi-million gates are there, and in terms of the one, I don't like how many of you remember know the timing path, but think in this way like okay, one data is traveling from one place to another place, and you have to do the timing analysis of this. So this is known as the timing path. Now, if in your design, let us suppose there are the 10 lakh of paths are there. And if I will ask you to do the analysis at a single, now obviously you will say like, okay, in a single run is going to, if I'm going to do the analysis, is going to be very difficult for me. So how we divide it, what are the different kind of a path, one by one, how you're going to do it. Okay, so all those things we are going to do as a part of this particular module. And then you can see like, okay, setup and hold recovery, removal, gate, clock gating, data to data check, all these kind of a checks we will talk about. So these are the checks which I'm 100% sure like most of you are aware of. You have heard about the setup and hold. So that's something we will discuss at a module 10. Okay. And there we will show you a lot of things like, okay, in terms of uh, exceptions, what are the different exceptions, what are the issues or the path group, how you can do it with the help of the GUI, non-GUI related part, the command. We will discuss that particular things at this particular stage. Next module is which is a 11th module is a SDC and the constraint writing part. So till now we were talking about the reports and everything, but obviously the constraint is also very, very important. Now, what is this constraint? So if you are going to do a analysis and if you are saying, okay, this is going to give me a 10 nanosecond of delay, and then I will say, oh no, I want this path supposed to give me a 8 nanosecond of delay. That means now I'm just talking about the constraint. Now that constraint related part, like, okay, how you're going to write the constraint. So those kind of a things we will talk at this particular stage. Even though the same thing, we are going to use it at a setup and hold also, setup constraint and hold constraint, but not only the setup and hold constraint, there are the different other constraints also. So we'll discuss about that particular part. So there may be a design, we will say, like, okay, if you have to write a setup constraint, how you're going to write the setup constraint. Okay, so those kind of a things we will discuss at this particular stage. Now, this is a module where maybe I'm not 100% sure whether I can cover each and everything just flawlessly, in the sense like in the short period of a time we can just do this particular part, because this is something which may take a lot of time also depending upon you people. So what I have done, like if required, then what I will do, I will just give you the some reference videos and all. You will just go through that particular part, and then when we are going to discuss, at least uh, I can just do it little quick. So there are the other modules also in above, like timing, arc related module was there. So if you will talk about the module number 6, here also there are the certain basic information about the timing arc. Maybe I will just give you the reference video, just go through that and we can just save time. So we'll see depending upon you people. If it looks to me a pre-recorded videos, if I will just give you as a reference and if you'll just go through and we can just save time. So we'll just save time there and just we will spend time on the another topics. There is a this much of portion is done. Then there is a 11A module which you can see here. This is mostly as a timing reports, like, okay, which I usually say is a post-processing report. So as this document is still, I'm just making changes. So I would like to add some module here. So that's the reason I just put it as a 11, or maybe in the final sheet, I can make it as a 12th module and I will just change the name of rest of the module. But important thing is here, once you will do all kind of analysis and everything, so there are certain reports are going to be there. Now, how you supposed to read those reports? That is important. Okay, because see, having a report is a different thing, but from what exactly you're going to do after having those kind of a report, how you're going to extract a particular information. So then maybe we will going to share you couple of scripts which is going to help you to extract some information. So mostly it is like kind of a text file. Now how you're going to understand those text file, that is basically the intention of this particular module. 12th module. Now this is the place from where the debugging part starts. So this module maybe take a lot of time, or it can be something like we just finish in a very less time, but usually it takes a lot of time because we have to tell you like, okay, if you're facing a certain issues in your run, in your like timing reports and all, when you're invoking the design and you're just facing a certain problem, how you're going to solve that particular part. Now, the best part of this sanity check module is like when we are going to do the first 11 modules, you have that certain test cases. On those test cases, if you come across a certain issues, then we will just discuss that particular time itself. And if blindly you're just following the instruction which we are going to give it to you, so obviously you will not face any problem. Then at this particular module, we are going to introduce those kind of a problem. And then we will tell you like, okay, if in your design, if you're facing this kind of a problem in your STR, and if you're going to face this kind of a problem, then what is the meaning of this and how you're going to solve that particular part. So sometime, for example, like here we have mentioned SPEF completeness. Now let's suppose the SPEF itself is not complete. I gave you the one example, like coupling cap. If the coupling cap information is not there, your signal integrity analysis and non-signal integrity analysis is going to be same. It is going to give the same report. Now you may be thinking like, okay, if both the reports are same, is it like I don't have any crosstalk? Answer is no. Is there is no problem with the tool. There can be a problem in the design. Unfortunately, your SPEF doesn't have all the data. So you have to go manually and you have to just check it whether that kind of information is there or not. Or there are certain parameters you have to see, okay, whether that value is coming as a zero or some number is coming. So those kind of issues are going to be the part of this particular module. And we are going to introduce basically, frankly speaking, if it is not there, we are going to introduce those errors and we just show it to you. And then we'll do rest of the part. 13 is like SDF and ST integration. Okay, so just try to understand this thing. If you have a design, you have done certain STA analysis, and then your team, like RTL team, they said, like, okay, we have made certain changes. So out of a whole design, they made a certain changes in the starting of your design, okay, initially. Now you have the two ways. The first way is you take that particular design as a scratch one. You just do each and everything. And then finally again do the certain ST analysis. Or maybe you can say like, okay, see, you have changed only this 20% of the design. What about the 75% of the design? In that particular 75%, why I'm going to overload my tool? Because I have already done the ST and everything and it is working fine. Let's use those numbers and just move forward. Let's do the things quickly. So there is a word that is known as a SDF back annotation. That means you have done something, you have already reached at the last stage of your flow. So at that particular stage, take out the SDF. SDF is a delay format file, standard delay format file. You just write out the SDF of the whole design. Then you come back at the initial stage, you say like, okay, I know this is going to be the delay of this particular stage. You just paste it there and do the analysis. It's kind of a iterations we are talking about. Okay, so you can understand this particular way. If I will tell you after the 5 year, this is going to be your future. Now then you will be like, okay, no, I need a better future. Then you make certain changes today. Okay, then your future is going to change. Am I right? That is something we are trying to do it at this particular stage. Right now, you don't know anything and you will do everything. Sometime in the life, we think like, okay, if I can go back and if I will just change that particular moment, the whole life is going to change. And obviously, in the life, we cannot do that particular part, but in the design, there is an option. You can just go back and you can say like, okay, let's change everything. So this is basically we are talking about the SDF and the ST integration. So we'll talk about a lot of things here, like how you're going to go back, just make the changes, how you're going to debug, mostly like annotation part. Okay, so I can change the name of the module also as a back annotated thing, but I think the integration looks good to me, so that's the reason I just mentioned like, okay, SDF and ST integration. Then 14th as a ECOs and fixes. Now ECOs is what? ECOs is the engineering change order. Same thing which I was just talking about the 13th module. There also I was just saying like, okay, predict the future and just do it. Like I'm just coming from the future and I'm just changing your things. Here also it is a kind of a same thing, but yes, uh, there are a lot of iterations usually happen. Like ECOs we do it. That means once we reach at the final stage, so the iteration which we usually say, the word which I just told you, like okay, iteration. I will just go back, just do the things. That's basically the part of a ECOs. So we'll discuss about all those ECOs, like okay, what is the timing ECOs, functional ECOs, what are the different techniques of the ECOs, what are the concept related to the physical aware ECOs, max trans, min pulse width, all those things we will talk about. Obviously, every stage, the tool related things also we are going to discuss, like, okay, what are the different commands which we are going to use to the ECOs, till what level tool can do it, till like where you have to do the manual thing. Now, one thing which is very important at this particular stage to understand, like, okay, if we need to change anything in the design, the analysis tool is not going to do that particular part. So remember this thing. So there are two kind of a design, two kind of a tool: implementation tool and the analysis tool. The STA is a static timing analysis. So the prime time is going to be the analysis tool. It is going to do the analysis, not going to change anything in the design. But if you have, if you come across like, okay, there is a cell, it is giving me a more delay, and now you want to change the cell to reduce the delay. So virtually maybe you can just do it in analysis tool, but you have to make changes, something into the design. For that, you have to go back into the design and you have to do it. So when it comes to the ECO, that's what we are talking about. Do the analysis in one tool, generate the ECO. You will say like, okay, this is my, these are the changes I want to do it. Then go to the implementation tool, make those changes, come back, then do the analysis, then go back. So those kind of a things we usually do as a part of the ECOs part. So we'll discuss those things as a part of a 14th module. Then there is a something like clock related part. Now let's, till the time we are talking about mostly on the data, then the clock related part is there. There we were just talking about little bit. Clock is not going to, we are not going to touch a lot about the clock, but still when we are talking about the setup and hold, people usually ask like, okay, something known as can we make it some changes in the clock or something, some other thing, can it going to fix that particular part? So this is basically where the useful is queue. Okay, that concept usually come. So related to the clock, we will talk about. And here also we are going to introduce the power part. So in a 15th module or maybe before that, I'm also planning to have maybe one or two sessions related to the power. When I'm talking about the power in terms of the dynamic power, static power, it's a conceptual part, okay? Um, so that you can easily understand, like, okay, when we are talking about, I'm just making a certain changes in the cell, how it is going to impact my power, and obviously the timing also. So 15th is a module where we will talk about the kind of a power integration, okay? It's like if you're going to make any changes in the design, how it is going to affect the timing and the power part. 16th as a RM flow, like till now we're just talking about something which is like the conceptual lab and everything, but in an industry you have to go through the certain flow. So till 15th also we are going to talk about a lot of flow, but this is mostly in terms of the Synopsys and the configuration point of view. So Synopsys usually provides certain methodology, RM flow, reference methodology flow. So how you're going to download that particular part, how you're going to set up the flow. So this is what we will do as a part of a 16th one. So this is the way I have generally did this particular part. Now there can be certain plus and a minus and all in this particular whole course. And there are this few special requests from few of you, like you need one session, maybe the half an hour, 1 hour for the basic Unix command. So that's something we are planning. Second thing is as a tickle part. So when it comes to the TCL, the normal TCL is the one thing, the Synopsys TCL is another part. Like, okay, because most of the Synopsys tools are based on uh, the TCL, and we usually say it's a Synopsys TCL. So we are going to talk about the Synopsys TCL also. And like tomorrow, if you have to write a certain script, how you're going to use the commands and all other things. So these two sessions also I have planned. Now where I'm going to put it, whether in the starting, on the last, in the middle, that's something still I'm just thinking, like, okay, how to structure the day wise schedules and all. So that's there. What else? Yeah, I think this is the something I have planned it. Now, in terms of the design and in terms of the tech node, so see, obviously we don't have a real PDK right now, and the real PDK which I have it that is on a higher technology node, where the Synopsys usually provide the tweak version of the real PDK. So they have 32 nanometer and 18 nanometer, 14 nanometer. So these two they have. So we are going to do on the both also. So even in some cases, maybe we can use the 90 nanometer also. So our main goal is where a particular concept, how we are going to uh, like explain you better way. If it looks to me, I can explain you the 90. I can just take the 90 part. If it is a like 14, I can just take the 14. So in that particular way, this all, if I'm not wrong, 4 or 5 different test cases are there, and we will just give you the concept in a different test cases, and you will also get those test cases, and so that you can also do the practice in that.